Hi everyone, welcome to lesson 22. We will be multiplying polynomials in this lesson, and actually in the lesson after this as well. 22 and 23 kind of go together, but I will give them separate videos. And then lesson 24 will be on dividing, and that will be the end of our first unit. So I think we're about halfway through. All right, so for multiplying polynomials, we actually start off doing a bit of review of something we've already seen, which is the product rule. That was something from our very first lesson on exponent rules. Multiplying is all about finding products. And so remember, the rule is when you multiply, what you do is add exponents, as long as the variables are the same. So to multiply a monomial, one term, by a monomial, one term, multiply their coefficients, so 5 times 2, and use the product rule of exponents, add the exponents. So for this first one, we would do 5 times 2, which is 10. And then we would add the exponents on the variables. Remember, there's a 1 here. If you can't see an exponent, it's actually a 1. Add those exponents. 3 plus 1 is 4. So we start there. So that's our answer. Okay, so 5x to the third times 2x would be 10x to the fourth. So now we are adding exponents as we multiply. Our second example, this is still a monomial times another monomial. Instead of a multiplication symbol, we have parentheses, but still, we will do the same type of thing, multiplying coefficients. So 6 times -3 will be -18. And we will add exponents. The thing is, we're not adding all the exponents. We're only adding exponents on the variables that are the same. So we'll take the j variables. There's a 1 plus a 2. That's j to the third. So 1 plus 2 is 3. The k to the fourth just stays as it is. So -18, j to the third, k to the fourth. Okay, good. And from here, instead of just dealing with monomials, now we're going to expand on that and start to look at binomials, trinomials, and longer terms as well. So now we'll see more parentheses. We'll see a monomial, or one single term on the outside of parentheses, and then more than one term on the inside. You've seen this before. If you took Intermediate Algebra Part 1 before this, which hopefully you did, we did cover the distributive property in that class. So this should be a review. It's beyond that in difficulty level. So just quick little recap. You would have seen something like, maybe like this. 5 times x plus 2. So 5 times x would be 5x plus 5 times 2 would be 10. That's the level that you might have learned, but now we're going to put some exponents in and some extra variables, etc. But that's the basic idea of where this is coming from. So instead of distributing just a 5, this first example of the distributive property is distributing an x along with the 3, sorry, 3x. Instead of just a number, it has a variable, is the point I was trying to make. 3x times 2, that would be 6x. 3x times, treat this as a -1x. 3 times -1 is -3. X times x, remember we do want to add those exponents. As we multiply, we add exponents. That's x squared. This is our answer. So a common mistake is to just do x times x is x. It's not. It's x times x is x squared. So if your terms had different exponents in the parentheses when you started, they should also have different exponents in the final answer as well. Let's do another one. 6fd is our monomial on the outside. We will distribute it to both terms on the inside of parentheses. Let's start with the first one. 6 times 7 is 42. F times f squared, we will add those exponents. 1 plus 2 is 3, so f to the third. D times d, there's another couple of exponents. 1 plus 1 is 2, so that's d squared. That's all my first term. 6fd times 7f squared d is 42 f to the third d squared. All right, next. 6fd times minus 6fd squared. Okay, 6 times 6 is 36. Positive times negative is negative, so I'll keep that minus sign there, 36. F times f is f squared. D times d squared. Now I'm adding the exponents. Again, 1 plus 2 is 3. Okay, so that one little more complicated, a little more details to keep track of, but still the same idea. Okay, good. Let us continue. Okay, here's where it gets a little bit different. The examples that we saw before were all involving monomials, or one term. What we're now going to see is binomials, or two terms. So we will now be doing a process that's sometimes called FOIL. FOIL is an acronym. It stands for first, outside or outer, inside or inner, and last. So there will be 4 terms when we do this. So with a binomial, 2 terms, times another binomial, 2 more terms, each one of those terms needs to get distributed. So here is one way to write this out. 7x plus 3 times 2x minus 4. First, you can distribute the 7x. That's 2 terms. Then go back and distribute the 3. That's 2 more terms. Then combine. Now it's been written out in this slightly different way here. The 7x is being distributed. 7x times 2x. Those are the first terms. 7x and 2x first. That's 14x squared. Then we have the outer terms on the outside parentheses, sort of on the edges of the problem. 7x times 4, that's 28x, and we do have that minus sign. Those are the outer terms. So we're still less than halfway because now we still have to distribute this 3. I usually draw the arrows underneath. That's just what I'm in the habit of doing. But if you rewrite the problem like this, it's almost like it's a second distributing problem. Instead of distributing the 7x, which we already did, now we'll distribute the 3 still into that second parentheses. 3 times 2x, that's 6x, and then 3 times negative 4, negative 12. So first, outside, inside, last. So we have our 4 terms. Usually, not always, but usually we can combine the outside and inside terms. A lot of the time, those are like terms. Those are alike and they have the same variables. So you'll be able to combine them. So that's what happened here. Negative 28 plus 6 is negative 22, and they both had x. So we kept the x in our answer. So a lot of times, you'll notice that a binomial times another binomial, it leads to 4 terms, but a lot of times the final answer will be a trinomial. Not always, but a lot of the time. So just notice that pattern. Let's now try an example on our own here. Okay, and you can rewrite it in many different ways. You can rewrite it in this way that you saw up here. I'm going to prefer to just do the 4 arrows kind of all at once to sort of minimize how much rewriting I'm doing. But you can show your work in whatever way makes sense. Just make sure you have a way of showing those steps. Okay, you're not jumping to the final answer. 3x times 4x, that's my first term. 3x times 4x is 12x squared. First terms, I should say. 3x and 4x are both the first terms in those parentheses. Okay, next. The outer terms. 3x times 6, that's 18x. Okay, now I'm going to move to my next terms. I'll distribute this negative 4 now. These are the inner terms. They're sort of together inside, in the middle of the problem. Negative 4 times 4x. Those are the inner terms, or inside terms. That's negative 16x. And then finally, the last terms, the ones that are last in the parentheses, negative 4 times 6 would be negative 24. FOIL, F-O-I-L, first, outer, inner, and last. I have 4 terms. Sometimes you're done at this point, but as I said before, a lot of times you can combine the outside and inside terms, and that is the case here. 18x minus 16x is positive 2x. Okay, and then we'll bring down the other terms. So we have 12x squared plus 2x minus 24. So see, there's an example again where you started with a binomial times another binomial and ended with a trinomial. Tri meaning 3 terms. That's a very common result that you'll see. So this is called FOIL. You're going to hear me say FOIL quite a bit in this course. I'll say just FOIL it, or make sure you FOIL those. What I mean is this process, okay? I mean multiply. So maybe a better term would be just multiply or distribute. I had a teacher friend who used to just call it double distributive, because as soon as you get beyond 2 terms, FOIL isn't enough letters. So we're going to be distributing with not just binomials, but trinomials and beyond, right? So if you can draw your arrows and you can distribute, it doesn't matter how many terms there are, the same process will apply. It just might be a little bit longer. Okay, let's keep going here. Okay, we'll see a couple more FOIL examples. Here's another one with some different variables and exponents. C to the 5th times C to the 5th. That's my first terms. C to the 5th times C to the 5th, that's C to the 10th. Just write this out first, FOIL. All right, so notice how I added the exponents there. 5 plus 5 is 10. I'm adding exponents as I'm multiplying. C to the 5th times F, there's a minus there. I'll just write minus C to the 5th F. There's not really any numbers to multiply. I mean, it's 1 times -1, which is -1. So there's my minus sign. Now I'll keep going. -3F times C to the 5th minus. So I'll just write -3. Now, I could just write F C to the 5th. That is fine. I prefer it to be in alphabetical order. So I am going to rearrange the order of those variables. I'm keeping the 5 on the C, keeping the F as it is. These are like terms, and it's more obvious now that I've rearranged the letters. Otherwise, you might not recognize that they're like terms. So anyway, I like to do alphabetical order. I think it's a good, kind of a good policy, keeps things organized, and it helps you to recognize like terms if you have them. All right, let's keep going. We still have our last terms. -3F times -1F. Negative times negative is positive. 3 times 1 is 3. And then F times F is F squared. All right, good. And now our final answer, we'll just combine these middle terms. The middle terms, let's see, that's -1, -3, that's -4, C to the 5th F. Okay, so I'm combining those coefficients. -1 minus 3 is -4, keeping the variables the same. So notice that we added the exponents when we multiplied, but when you're adding the terms, you keep the variables the same. So use the product rule, add the exponents when you multiply, but when you combine like terms, you're adding the coefficients, but keeping the exponents and variables the same. Okay, it's a lot to keep track of, I know. Bringing down everything else. C to the 10th is still there, and then 3F squared. That is it. So that's my final answer. So that was a little more complicated. 2 variables, higher exponents, but we still did FOIL, right? So we had binomial times binomial. We had 4 terms, combined those middle terms, and we ended up with 3 terms, a trinomial for our final answer. All right, here's another one. And yes, there's fractions, and that's okay. So let's do it. FOIL. You don't have to write this every time or ever, but if you're new to this, I think it can help keep you organized. Okay, so let's multiply 1/2 x times 1/6 x. I'm just gonna write my work out a little bit here. 1/2 times 1/6, I do get to multiply across and get 1/12. And x times x is x squared. All right, 1/2 times 1/5. 1/2 x times 1/5. Once again, just multiply across. 1 times 1 is 1, positive. 2 times 5 is 10. And then that's just x. Now for my inside terms. -3/5 times 1/6 x. I can multiply across, or I can reduce. Let's see, which should I do first? If I multiply across, This would be 3 over 30. If you have 3 over 30, you'll be able to reduce by 3 and get 1/10. I can just reduce now though. So the 3 and the 6, I can sort of cross cancel here and divide them both by 3. Now when I multiply across, it's minus 1/10 x. Okay, otherwise it would have been minus 3/30, which would then have to still be reduced. So I chose to reduce first rather than later. And finally, our last terms, negative 3/5 times 1/5, multiply across. That's going to be negative 3 times 1 is negative 3, and then 5 times 5 is 25. Okay, so take a look at our 4 terms. 1/12 x squared plus 1/10 x minus 1/10 x minus 3/25. Now we get to combine our middle terms because they are alike, because they both have x. And I was all ready to get common denominators with you, but we already have that. And look, they actually cancel out. Plus 1/10 minus 1/10, cancel. It adds up to 0/10. So we don't even need to write anything for our middle term. So this is a case where the pattern does not hold. We are not going to end up with a trinomial at the end. It's just going to be a binomial. So 1/12 x squared and then minus 3/25 is our final answer. Okay. So it's not always 3 terms. Sometimes different things happen. In this case, the middle terms just totally canceled out. So there's your fraction example. You will see some fractions in the homework. So notice how we had to multiply across when we multiplied our fractions, reduce if possible. Sometimes you will have to do some more work adding or combining like terms, getting common denominators. This is something we've worked on already in this class. So it's something you've seen already, but you'll continue to practice it. All right, good. So we've done some FOIL. Now we'll build on that. Instead of double distributive, we can call this triple distributive. That's not an official term, but you can make it one if you want. It's going to feel like we're using FOIL, but it's going to be longer. So instead of 2 terms times another 2 terms, it's 2 terms times 3 terms. Instead of 4 terms, F-O-I-L, it's going to be 6 terms. And I don't have a 6-letter word for you, unfortunately. It's just going to be 6 terms. So let's distribute. So we're using the distributive property. First, I will distribute C. And you can see I'm going to use columns to line up like terms. This is a way that you can stay organized. You don't have to do this, but you'll see it's just a way to kind of organize all your stuff happening here. All right, C times C squared, add the exponents, that's C to the 3rd. Then C times 5C, add the exponents, that's 5C squared. Again, C times 25, that's 25C. Now, I can just keep going and write it one long horizontal line of terms. That's completely fine. But as I said, I like to line up the like terms using some columns. So that's what I'm going to show you. So now we'll go back, and now we will distribute this negative 5. Negative 5 times C squared is negative 5C squared. See how I'm lining it up with the other C squared term? Okay, so I'm essentially writing a new row, but it's going to be shifted over sort of one space to the right. Let's keep going. Negative 5 times 5C is negative 25C. Negative 5 times 25 is negative 125. So see, now all my like terms are just ready to go. They're all lined up. Now I'm going to add C to the 3rd plus nothing is C to the 3rd. Positive 5C squared minus 5C squared, those cancel out. So I have nothing here. Positive 25C minus 25C, canceling again. And then I just have minus 125. So this is a special case. Several weeks down the road, we're going to be looking at some special formulas. And this is just a little preview of that. So I will resist telling you more right now, but this was intentional that this problem was set up this way. This is something to do with perfect cubes. So this is 5 to the third, or 5 cubed. But I'll leave it at this. All you needed to do for this problem is distribute and combine like terms. And no, they don't always end up quite this nice. So let's see another one that's longer. All right, our next example will be even longer. It will be 3 terms times another 3 terms, which will be 9 terms. Okay, so I'm going to actually have 3 rows this time, but it's the same idea. I'm still drawing my arrows, still adding exponents as I multiply, and then I'm going to still be combining like terms. So even though it's longer, you kind of get the hang of it. You kind of get into the flow of it. All right, so w squared times w squared, w to the 4th, w squared times 6w, that's 6w to the 3rd, because I'm adding that exponent. Oh, that was supposed to be an arrow here. And then w squared times -8 is going to be -8w squared. That's my first row, because I've now distributed all the w squared. I've distributed w squared to everything in the parentheses here. I don't know why that middle arrow didn't show up, but I did it. Now, so I'm done with that. Now I'll distribute the w. W times w squared is w to the 3rd. So look, see how I'm lining that up? Shifting to the right here. W times 6w is 6w squared. Finally, w times -8 is -8w. Okay, so the like terms are starting to line up here. I have one more term to distribute, so I'll do one more row. Now I'll distribute the -1. -1 times w squared is -1w squared. I do not need to write the 1, but it's kind of helpful if I do, especially in the middle of a problem. So that's why I'm doing it. -1 times 6w is -6w. -1 times -8 is +8. All right, and now we very carefully add or combine or collect all these like terms. But they're all organized. They're all lined up and ready to go. W to the 4th is just w to the 4th. 6w to the 3rd plus 1w to the 3rd is 7w to the 3rd. So now in this step, I'm adding the coefficients. I am not adding exponents. So be careful, don't do 3 plus 3 is 6. The degree should be 4, okay? The highest exponent should be 4 here. Okay, next. -8 plus 6 would be -2. -2 minus 1 would be -3w squared. Okay, keeping the 2 all the way down. -8 minus 6, that's -14w. And then finally +8. So that was a nice long answer. Nothing really canceled out in that one. So I hope you can see the progression there from, we started out multiplying monomials, then we did the distributive property, then FOIL, and then we kind of got longer from there. All right, yes, so what's next in this, I just put them all together in the same PowerPoint. What's next in this PowerPoint is lesson 23, which I will give its own video. I do want to, it's not going to be a lot, but there's just a couple examples from the homework I'd like to show you right now. This is lesson 22, and I want to look at number 9 to start out, because it does involve fractions, and I found this one just to be maybe slightly harder than the one that we did. Okay. Because the fraction example I gave you, I think things canceled out almost too nicely. So here's number 9 in homework 22. So we'll go ahead and just FOIL like we've been doing, or distribute like we've been doing. B times b is b squared. B times -1/5 is -1/5 b. B times -1/2 is -1/2 b. And then negative times negative positive. 1/2 times 1/5, just multiply across. 1 times 1 is 1. 2 times 5 is 10. Okay. Again, in the notes, I think when we did a FOIL problem with fractions, it canceled out in the middle, and I wanted to show you one that doesn't cancel. So we have to combine these. Let's get a common denominator to to combine these fractions. We can do 5 times 2 is 10. So I'll do 5 times 2, 1 times 2. So that's negative 2/10. And then times 5 times 5. So that's negative 5/10. So if I put those together, that's negative 7/10. Okay, now if I put everything back together with the variables, b squared minus 7/10 b, and then plus 1/10. So that's all. I just wanted to show you that one. You should already know how to add fractions with common denominators, but inevitably I always get questions on this problem, so I wanted to get out in front of that. If you're still stuck, you can still ask me about this one. That's okay. All right, so b squared, let's see, minus 7/10 b plus 1/10. All right, good. Let's see. I wrote down a couple others and now I forget why I wrote them down. So 13, 14, and 18 were the other ones. Let's see if I can remember why I wrote those down. Oh yeah, for number 13, this one we'll see the middle terms cancel. I think we did see that in the notes. Here's what happens. So you get 9w squared. We have 2 variables here. I just want to make sure you saw enough examples with that. This is just WP. So minus 15 WP and then plus 15 WP or PW and then minus 25 P squared. Okay, so notice the 2 variables for those middle terms. I wrote WP for both, which violates my alphabetical order rule, I guess, but I'm going with the order of the problem. And then I guess I just wanted you to see that these terms cancel. Negative 15 plus 15 cancels, so it's just 9w squared minus 25p squared. So that's kind of a unique problem there that ends up with just 2 terms. I'm not going to type in the answer, I just wanted you to see that one. That was 13. 14 is kind of similar in that the 2 middle terms kind of look like they're going to cancel, but I don't think they are. So x times x, x squared. This is minus xc. I'll just write minus cx here just because, just to show you that it's okay. Negative times negative is positive c squared. Okay, so it almost feels like there's no numbers in this one. There's a 1 here and there's a 1 here. Both of these are like terms, minus 1xc. This is also minus 1xc. I can just rewrite it. It feels like they should cancel, but they do not, okay? They're both negative, so you have to combine them. It becomes minus 2xc. So my final answer is x squared minus 2xc plus c squared. Okay, so just be careful there. When you have 2 of the same term in the middle, if the signs are the same, you have to combine them. It's only if the signs are opposite that they would cancel. So that's what that one was. All right, and then number 18, I think was another fraction one. I'll just skip ahead to that one. Okay, let's see. Yeah, it's another fraction one, might as well. So feel free to be done at this point. Number 18 and then number 19 is a decimal one. Honestly, I just use my calculator to help me FOIL. So I don't think I need to do that one with you, but feel free to be done. Or if you want to see one more fraction example, stick around for a couple more minutes. And that's all that's left for lesson 22, and we'll pick up in lesson 23. All right, so one more FOIL problem here. 1/3 times 1/9, that's 1 over 27, x squared for the first terms. 1/3 times 1/4 would be 1/12. So what I'm doing right now is just multiplying across, meaning multiply the numerators and multiply the denominators. That was my first 2 terms. Let's see, here's my next term coming up. 3/4 times 1/9 if I multiply across. 3 times 1 is 3. 4 times 9 is 36. Oh, and I can reduce that, but I'll come back to that. And then my last one, 3 times 1, that would be 3, 4 times 4, 16. Okay, so combining like terms. Here's the thing, I could reduce 3 over 36 to 1/12. I could have reduced back here with the 3 and the 9, 1 and 3. If I were to write it out, I would have noticed that. Let's say I didn't notice it though. Let's say I just went ahead and got common denominators. 12 goes into 36, so I could rewrite this as 336x minus 336x. Either way, at some point you'd realize that those middle terms do cancel out. So this one is more like the one you saw in the lesson. The final answer would just be 1 over 27 x squared and then minus 3/16. So the middle terms are just gone. All right, so that's that one. All right. Good. Okay, I will end here. That was lesson 22. Lesson 23 is really a continuation. It's more on multiplying, but it's focusing on special products. So I'll end the video here and I'll see you soon for lesson 23.